the activities that you and your team are going to work with in week 6. This is when we're programming the search and rescue algorithm, where you're looking for the aluminum square within the blue or black taped box. To complete this activity, you and your team will need to work with just one robot rather than 3, and you will build off of the Stop at the Line program that you and your team put together. Before we get started with the programming, let's take a look at the flowchart. You'll notice that this flowchart is very similar to the flowchart we worked with last week with the Stop at the Line program. Here, we just have an additional decision term where we're looking to see if the light sensor value, abbreviated here is LVS, is less or greater than a value for the aluminum square, which is a new piece we've added. And we also need to expand on the procedure for what the robot will do when it encounters the boundary line of the box. So let's talk through our flowchart. Again, we're going to start. We'll have the robot drive forward and check the light sensor value just like it did last week. Now when the light sensor value is less than the tape, if that decision is yes, then you and your team will need to come up with a procedure and code that procedure for what the robot should do to turn around, should back up for a certain amount of time and rotate, or if it should just rotate right away in order to move away from the boundary line. Remember that the robot needs to keep at least one wheel inside the boundary box at all times to not be disqualified. If the light sensor value is not less than the tape value, then we'll go on to this next decision in the flowchart. This decision diamond looks to see if the light sensor value is greater than the aluminum square value. If the light sensor value is greater than the value we've set for the aluminum square, then the robot should stop and hold for 5 or 10 seconds to allow you and your team to stop the stopwatch at the end of each run. However, if the light sensor value is not greater than the aluminum square value, then you should return to the start of the loop function again, just like we did with the Stop at the Line code last week. Let's take a look at how that programming will work. Before you start to actually run the program, you and your team members will need to again run the light sensor calibration code, determine what the values are for the light sensor over the boundary tape, table, and also over the aluminum square for your program. Make sure you record these 3 numbers and then take the averages so that you can use those averages as a starting place in your if statements. Remember, just like we encountered last week, you may need to raise or lower those averages once you start running the code with your robot. Alright, after you and your team have finished debugging the search and rescue algorithm on your robots, you will need to start running the timed trials. You'll need to take 5 timed trials, 4 at each of the corners, and then the 2 on the other side, and then the 5th trial will be placed at the center of the box. Your instructor will have a diagram for you and your team members to follow. Remember, you're going to need to take 3 tests at 3 different tables, and then there'll be 5 tests at each table for a total of 15 tests. However, if you have 3 team members, recommend that you load this code onto the 3 different robots, so each team member will run the 5 tests at only 1 table each. So go ahead and take a look at how the robot will run once the search and rescue algorithm is programmed. So start program by plugging in your robot. Wait to start your stopwatch until the robot starts moving.